Hi, this is Suey778 coming at you, and I have yet another multimeter to show you today. And today's candidate is the Tilswall FY8233X manually operated multimeter. So let's go ahead and get to the unboxing here. As you can see, it comes in a plain brown box. And you get a nice little case with it. You get a manual, kind of small, but it is legible, so that's good. I'll show you some specs here real quick. I think that's all of them. We're going to cover everything though, so don't worry. You also get a warranty card, and I believe this comes with a 2-year warranty if I'm not mistaken. I found this meter, by the way, on Amazon.com. Normally priced at $19.99. Right now they've got a 25% off coupon, so I got this multimeter for basically 15 bucks. Okay, inside the case, you get some leads. Get some batteries. These are a pair of AA's. And you get the meter. Pretty nice looking multimeter here. Let me go ahead and get this set up on the bench and we'll go over the details. Okay, now for a general overview of this multimeter. We're going to go from top to bottom. On the top here, we've got your display. It is a little bit smallish display, but it has fairly sharp numbers in the display and a good backlight to it that's fairly even. You've got your backlight button, which, by the way, does not stay on permanently, and there is no way to make it stay on permanently, but it will give you 45 seconds of light. Then you've got your standard freeze frame. As you can see here, this is a manual mode multimeter. There is no auto modes on this unit at all. So we'll just go counterclockwise. Got your off switch, got your AC voltage, DC voltage, and millivoltage. Got your resistors from basically 600 ohm range to 6 mega ohm range. You've got your continuity and your diodes. You have your DC amps, milliamps in a couple of ranges here, 600 milliamps and 60 milliamps plus 10 amps, and also AC 10 amps and 600 milliamp range, capacitance, non-contact voltage, and alive, where you basically just take one probe and stick it into a jack or whatever you're messing with and determine whether it is hot or not. Down here we have 3 jacks, one of which is closed up here. We're going to take that off here in a few minutes. You've got your common jack here. Everything else, including milliamps, goes here. The only thing that this particular covered jack is for is just the 10 amp current. You will see that there's a little bit more honest advertising on the face of this particular multimeter, as it says 600 volts max, category 2. There is no mention of category 3 here anywhere. And there are a pair of ceramic fuses both on the 10 amp and the milliamp input. The build quality of this is actually quite good. The plastic is actually kind of a lightweightish kind of plastic. But this sheath, glove, whatever you want to call it, that goes around it adds a lot of stability and durability to it, although I would not get too rough with this thing. In other words, don't start dropping it, off of second-story windows or whatever. It is a fairly small multimeter. As a matter of fact, let me pull out my Cen-Tech, and you knew sooner or later my Cen-Tech was going to show up on this channel. Let me pull that out real quick. Got it in a box down here. But this is just strictly just for a size comparison. This also happens to be my only other manual multimeter that I personally own. Let me get it there. It looks like it's all the way in the picture there. As you can see, it's quite similar in size. The FY8233X is a little bit taller. It's about the same width, and it's a little bit thicker. I'd say about maybe 1/3 of an inch thicker, maybe 1/2 inch. But anyway, just for size reference there. All right, we'll get that out of the way. The battery compartment is actually on the back here. It's located at the top, and we'll let's go ahead and take that out while we're looking at it. It takes a couple of AAAs, as you can see here, and it is a metal or a brass insert. Looks more like brass to me than metal, but maybe it's metal. And then of course you got your stand here, which is kind of like the Anning Q10. I think this particular stand is a little bit more robust, but I mean it does stand up well, as you can see here. Okay, let me go ahead and turn this thing on. If we can get it to hold still here. Has a fairly loud beep. I'll go ahead and put the backlight on here so you can see it. And you go through the various ranges here. And as you can see, this is a pretty clicky switch. But it seems fine. I'm not seeing it get stuck between anything. So there you go. These leads, they're pretty decent. I'll go ahead and take them out here. These are actually quite similar to the ones that you find in the HT200B, the Kaiweets model. They have somewhat shorter jacks, and they look very similar to them. These are decent leads. I would just say, just basically kind of in the middle of the road for cheaper leads. They work fine. I find them to be better than the ones that came with the Anning Q10, to be perfectly honest. But you know, they're okay. They're usable. Not perfect. You can also use probe masters with this, and of course we will be using our probe masters to do the testing. Again, like I said, 6,000 counts. Goes up to about 6050 before it loses the decimal. And we'll get to the protection when I open this up. So let's take this thing apart and let's see what it's got inside. Okay, we're going to try a little different angle this time. As you can see, we've got it open and pretty tiny little board. The interesting thing about this, of course, is right off the bat what you see, you've got a $15 meter, you've got 2 PTCs, you've got ceramic fuses. These look like split jacks, pretty standard for this level. They're in there pretty good, they're not going anywhere. Also, if you can see it, you may not be able to see it behind there, but this has the same resistor that the HT118A uses for in place of a current shunt. There is no current shunt on this particular model. Right here, right down in here, you've got some, looks like some more resistors and diodes for protection. Got some pretty good sized resistors here and here. They're not huge, but for this board they look kind of big. I believe here's your speaker right here. Here is the blob covering the processor right here. As you can see, this was built on June 17th, 2020, right here. Looks like the controller circuit for the LED display is actually on the opposite side. I'm not going to take this out. This, of course, is your battery connector. Kind of interesting that they elected to just use a plug instead of other methods that I've seen. And let me pan out just a little bit here. Give me just a second because I need to make sure I get it in the camera here. Oh, we went too far. Well, actually, let's zoom in real close and show you what we got. That little resistor I was talking about in place of the current shunt is right here next to this red wire that's jumping down to the common jack right here. But anyway, the interesting thing that they have in here, and this is the back side of the LCD display right here. And like I said, I think the driver is probably on the opposite side of this board. But if you notice this red wire going here, like so, it's just an open wire right here. And basically, that looks like your NCV. So, but anyway, I was very pleasantly surprised when I opened this to see that it actually had 2 PTCs, because that puts it ahead of, well, basically the vast majority of multimeters under $50 in terms of protection. I mean, they are small PTCs, but there's 2 of them. So that was nice to discover. Again, it's actually a pretty clean looking board. I don't see like a lot of crap or anything on it. The soldering looks pretty good on most of it that I can see. I can't really find anything to fault this design. I mean, it's a very basic squarish design. I mean, it doesn't get much more simple than this. But anyway, so now that you've seen the insides of it, let's put this puppy back together and let's do some testing. Okay, and before we get started with that, let's go ahead and take the coverings off of this. You might notice in the camera that the display looks scratched. It's actually the cover, and there's a reason why I waited, and that reason is that this condom or sheath or whatever you want to call it, it is a royal pain in the rear to get this thing back on. So yeah, it endures some scratches. So the first thing we'll do is take off this little doohickey right here. There we go. Oh, that took some doing to get that little booger off of there. Can you just feel the anticipation? Yeah, whatever. Let's just get it off there and get on with it. And our FY8233X is officially deversionized. Okay, first up we're going to do the DC voltage test like we always do. So let's get the backlight on here. I've got it in the range of 6 volts. We're going to start with 2.5 and work our way up here. So let's go ahead with 2.5 volts. Okay, we are reading 2.502. Looks good. Here's 5 volts. That's a little bit slow and settling, but we are working up to 49.98, 49.99. I would say that's pretty good. Give it a couple more seconds to see if it'll hit that 5. Yeah, okay, well, that's close enough. Good enough for me. All right, now we got to switch over to 60 volts because we're going to move up past 6 volts. Here's 7.5. And we're getting 7.49. Looks pretty good to me. All right, let's go ahead and go to 10. Okay. Now we're at 9.99. Doing pretty good so far. All right. Let's go ahead and jump up to 32 volts. Let's see what it does there. It's a little bit slow. They claim this display does 3 samples per second. I'd say it's more like 2, but that's okay. And we're getting 31.98. So all in all, pretty good on the DC voltage test. All right, let's go ahead and do the voltage test here. I've got my outlet on. And we are getting 123 volts. And as you can see, it reads AC voltage only in whole numbers. Not the most precise thing in the world, but it still gives you an idea of where your outlet is at. A very good idea. But if you're looking for more precision, well, this is all you're going to get with this meter. Okay, here we go with the DC current test. We're going to start off at 5 milliamps here and work our way up to 150. You'll see that I'm in the 60 milliamp range here. That's one nice thing about these manual meters is you can kind of zero in a little bit better than auto ranging. Okay, let's start off with 5 amps here, or I'm sorry, 5 milliamps. Okay, we get a light. And we're getting about, well, it's reading it as about 6 milliamps. All right, let's dial that up to 10. Okay. It's balancing out a little bit. Still reading it about a milliamp over, but not too far off. All right, let's go to 20. Okay, getting brighter. All right, getting about, now 21.44. Not too bad. All right, let's dial it up to 50 here. 50 milliamps. Getting bright. 50.33. Okay, 51.33. Looks like this one on average is about 1 to 1.3 milliamps over. Okay. All right, let me shift up to 600 milliamps so we can go to 100. Okay. All right, here we go. Okay, there's 100, and it's reading it as 100.4, 101.3. All right, again, about the same trend. 101.3, not too bad. All right, let's go ahead and push it up to 150. Let's see what we get. Okay, we are getting 150 even. 151.2. All right. Well, it did worse than the HT118A, I think, but it did better than the NQ10. So, not too shabby on this. Okay, the first thing I'm going to do here is the continuity test with the included probes from Tilswall. Had to look at the name. Oh, I keep forgetting it. But let's go ahead and give these a shot. I did clean these with some denatured alcohol, so we'll see how these do. Yeah, not that good. I mean, they would work. I mean, like say if you're doing continuity, and we'll just show this real quick here on camera. If you're going down a row of where you have to check rows and rows of things for continuity, you can just so it's at least useful for that. Anyway, let's get the probe masters in there and let's see how that does. Okay, here are the probe masters. Nice latch. Super fast. This meter would really be good for doing that kind of road checking, especially with a good pair of leads. Although, like I said, the originals would work. All right. So first up, let's go ahead and we're going to do some, let's go ahead and get the diodes done since I'm on diode mode already. Okay, red, lights up dimly, no reading. Yellow, same deal, lights up dimly, no reading. Green, lights up dimly, no reading. Blue lights up ever so dimly. I doubt you can see that on the camera. White, nothing. Okay, RGB, red, lights without a reading dimly. Green, same deal. Blue, lights up just barely. So it will light up red, yellow, green, and blue dimly, but you do not get any readings on this. That's a little disappointing. But anyway, let's move on. Let's go ahead and do the the regular diodes. Okay, first up we've got the rectifier. Okay, 513. Next up is the fast recovery, 498. Okay, next up is the Schottky, 145. That's kind of low. Next up is the switching diode, 576, 577. Okay. And last up is the germanium, 240, 241. That's kind of low too. All right, it's usable. I'm not too thrilled about that low Schottky reading, but you can still tell that it's a Schottky. Okay, next up, let's go ahead and go to resistance. So again, this is a manual meter, so we're going to have to advance manually, as they say. All right, starting in the 600 ohm range. This is a 10 ohm. Okay, we're getting 9.7. Not too bad. Here's 100. 99.8. 220. 219.0. Okay. 330. 329.6. And last, we got a switch. This is a 1K. 1K. If I get my probes on it, that was my fault. 993. Okay, 2K. 2004. 2005. And we'll call it 2004. 5.1. 5.124. Good. Switch again. 60K mode. It's for 10K. 9.96. All right. Switch again. Switch. Where'd that come from? $100.5. Wavering between 100.4 and 5. That's good. And last but not least, 1 meg. And I'm getting, I'll light that up again. Okay, 0.997, pretty good. All right, let me bring the resistance substitution box down here. Test to see how high this can go. I'm guessing it's going to be 6 megs. Okay, and just to show you, down in the 600 ohm range, it does show the resistance that, you know, the 0.2, 0.3, in this case 0.3. But we're just going to check 6 meg, so that's fine. Okay, 2 meg, a little bit low. Oh, there we go. Well, okay, about 1984, 85. All right, let's try 3. 2977. Hold on a second. All right, we'll call it 2975. Here's 4 meg. 3957. Measuring at a tad low on these higher ranges. Okay, here is 6 meg. 5942, 5944. Okay, let's try it with the 1, 2, and 3. $5,965, not too bad. Let's see how high we can take it. Yep, just over 6 takes it over limit. So pretty good on the resistance. All right. Let's get that out of the way. Okay, next up we're going to do capacitors. I only have one setting for capacitors. This thing is a little bit weird with capacitance. It will read as low as 100 nanofarads. In fact, let me grab that box real quick. I can only do one setting on this. Okay, on this I got it set for 100 nanofarads. Reads it just fine at 0.1 microfarads, which is what it should be. Okay. So we know it does read that low. It's not going to read any lower. I tried it earlier. It does not work. And I'll show you when I get to this the green board. Okay, on these capacitors. Not even going to bother with the 22 puff. I know it can't read that. This is supposed to be a 100 nanofarad right here. It's more like 86, and as you can see, it's reading it as 0.1 microfarad, so it's kind of close, but yeah, it's just the resolution that's the problem there, really. Here's the interesting thing. When you go to 1 microfarad, it's only reading it as 300 nanofarads. That's not good. Okay, once we get to 3.3, seems to make a recovery. Yeah, it's getting 3. Should be more like 3.2, but that's close enough. Okay, next one is 6.8, and we're getting 6.2. Okay, next one is 10 microfarads, 9.9, good. Next one is, I believe, 22. No, 33. A little bit low. 29.1. Okay, the next one is 47. This should read as 44-ish. And we are getting, looks like 42.2. Let me get my probes back on there. Yeah, 42. A little bit low, but close enough. Okay, next one is 100. 98.2. Okay. Next one is 220. Come on. Yeah, 210.2. This one is a 470, and it should be more like a 405, 410. Not bad. And I forgot to test the voltage for the diodes, what the Tilswall is putting out. All right, let's do 1,000 microfarads. We'll get to that here in a second. 937, and typically I read between about 942 and 952, something like that. So yeah, it's close. And 2200 microfarads, should be able to read this one. There we go. Okay, 2092, and usually what I get is something between 2115 and 2120. So yeah, that's pretty close, you know, for this capacitor. Not going to bother with the big one. I know for a fact I won't do it. It's just going to give me an over limit. That was the first one I tried because I was just curious. But anyway, there you have it. That's pretty much going to wrap it up for the test. Oh no, we got one more thing to do. We got to do the live test and the non-contact voltage. So let's do that real quick. All right, so first we're going to do the live test. So basically this works the same way the HT118A works. And then yeah, we'll check the voltage this is putting out too. We'll do that last. Okay, the live works. It's basically just where you plug one probe into the jack. And let's go ahead and do NCV here. All right, we'll do the plug first. And remember, we're playing with basically just a red wire. It is picking it up. And get within an inch. So it doesn't work quite that bad, but this should be reading as high here, so that's a little bit anemic. Let's try the laser or the LED light. Okay, that is reading high. So it's fair. This is one thing I keep forgetting to do in these reviews. We're just going to test the output voltage on the diode setting and the on this Tilswall. Let's see what we get here. There we go. 2394. Well, that's why I can only do so much, and that's why, I mean, it can light up the blue, but just barely. Okay, well, that's going to wrap it up for the test. So let's go ahead and get to the conclusions here. Okay, and that brings me to the pros and the cons of the Tilswall FY8233X manual multimeter. For the pros, very good accuracy on most functions, I would say. There are some discrepancies, and we'll get to that in the cons. Overall, for a $15 meter, very good accuracy. You know, there are a few weak spots, but for the most part, it's a solid meter. It's easy to use, and it's cheap. It offers a lot of bang for the buck, especially for the $15 price that I got it for. At $20, it kind of depends on what you want, but at $15, I would say this is definitely worth getting. It's got a really good display, better than I thought actually, and there's really not any hot spots that I can see in this display, so that's nice. And it's viewable at most angles. The only angle where I had trouble is when you're looking above, but anywhere off to the side or below it, it's just fine. Works great. It has above average protection for such a cheap digital multimeter. 2 PTCs, fair amount of resistors and diodes in there. I mean, it's not superstar, and I mean, I would not recommend this for heavy industrial use. But for a $15 multimeter, those 2 PTCs alone put it ahead of most multimeters that are $50 or less. There's a couple of exceptions. The HT118A being one of them, and this kind of looks like what the protection was modeled after, to be perfectly honest, especially with the current shunt being the same resistor chip, and also the dual PTCs, almost in the same location. Another one would be the Fluke 101, which is around $50 right now. It's actually, the prices have shot up on that a bit lately, and that's when it comes to $50 multimeters and protection, the Fluke is in a league by itself, basically. I love the small size of this thing. This is a thing that's begging to be thrown into the glove compartment and be used. This would be a perfect multimeter for that kind of use. It's small. I mean, it's almost as small as my Cen-Tech. This thing does carry a 24-month warranty, which is pretty decent. You can't really shake a stick at that. And like I said, I bought this on Amazon, and there is a 25% off coupon right now for it. So if you want one of these, the time would be now. Now, whether this is going to be continued in production, that I do not know, because I did see that they are coming out with an HT118C, which is basically a manually operated version of the HT118A. I have not found those anywhere yet. I don't know if they're available yet or not. Okay, on to the cons. Obviously, some of the functions that it's missing. It has no frequency or duty cycle measurements, and obviously no temperature probe or any of those kind of functions. No auto mode. The AC voltage can only be read in whole number readings, which to me, that's not a big deal. It might be to somebody out there, but I mean, when you're checking AC outlets, I mean, generally, there's a general range of numbers you want to see. The decimal probably isn't that important, so just something to keep in mind. There is no voltage measurements on the LEDs, and some of the diodes are measured a bit too low. In the case of the Schottky, it was about 40 counts below what it should have been. And on the germaniums, I'd guess about 25 counts. It's not terrible. You can still identify the diode. The other diodes, it did just fine. In fact, it was fairly close to the fluke and the 2C42 on the other threes, on the other three types. But yeah, diodes is definitely one of the weaker links in this meter. And last, the capacitance has a gap somewhere between 100 picofarads and 3.3 microfarads where it cannot measure accurately. That's kind of a bummer. Capacitance in general, it has a tendency to measure a little bit low, but it's just a tiny bit low. It's definitely usable for it, but just keep in mind if you get one of these that you're going to have that dead spot. Now, I don't know exactly where that dead spot is, but it's somewhere between 100 picofarads and 3.3 microfarads. Okay, and that brings me to the conclusion. The conclusion on this is that the Tilswall F8233X is a solid, basic, no-frills, manually operated meter with a 6,000 count range that has all the basic measuring capabilities with accuracy that generally met or exceeded my expectations. There were a few exceptions, which I just mentioned. This meter is perfectly fine for use around the house or on an electronics bench as long as the user does not need to measure frequency or duty cycle or have super reliable diode readings. It's definitely a better choice in my opinion than any low-cost 2,000 count meter, including the Cen-Tech and some of the other, $10 to $12 ones that I've seen floating around the universe. But yeah, it's a pretty good little meter. I do like it a lot. Just for its price and its protection and, its general overall, utilitarian kind of approach to things, while still being a Spartan. Yeah, I would say we have to give this a thumbs up. I like this meter. I'm going to keep this meter. This is probably going to be thrown in my glove compartment. Anyway, until next time. Oh, and by the way, I did put a link to this product in the description, so if you're interested in it, go check it out. I'm not getting paid to do this review. I do all my reviews out of my own pocket, just so everybody knows. Anyway, until next time, this is Sui778 bidding you a good night, or whatever time it is where you live. Thanks for watching.